So guys, we are continuing with our lecture series data structure and algorithm in Python. So we were discussing with arrays in previous lecture. I show you how to make arrays and some methods I also told you, like append, insert, remove and lookup methods. So coding part of arrays we have already done in Python. If you have not seen the previous lecture, please go and see it. Now today we will discuss how arrays are stored in the memory. Okay, so let's get started. So first of all, I want to tell you two important points before moving forward to the lecture. So first of all, elements in the arrays are stored in the continuous location in the memory, and when we traverse to all the elements, or in worst case we have to traverse to all the elements, the time complexity of the methods becomes O of n. Okay, so these 2 points will be cleared after seeing this lecture. Okay, so let's get started. So guys, this is how the arrays are stored in the memory. You can see that I have initialized array with 4 elements: apple, orange, grapes and mango. Okay, so you can see that this is our memory, and this is the address of the memory, and this is a 32-bit I'm considering 32-bit computer, so it will take 4 bytes, and this all data will be stored in bytes. Okay, but just for easiness I am showing you this apple, orange, grapes and mango. Okay, they in their original form. So you can see that these apple, orange, grapes and mango, these are located in the memory in a continuous address. Okay, so you can see that apple has address 6351, orange has address 6352, grapes has address 6353 and mango has 6354. Okay, so whenever you assign array, then what happen, that all the elements in the array goes to the memory, and it can be stored in anywhere in the memory. So it is not necessary that address this is 635 always 63 starts from 6351. It can start from anywhere, but always all the elements of the array will be stored in a continuous memory. Okay, that means continuous location. So in this way these are stored, and you can see that index, we have already discussed in the previous lecture that the array's index starts from 0. Okay, so you can see that index of apple is 0, orange is index of orange is 1, index of grapes is 2 and index of mango 3. Okay, so in this way the arrays are stored in the memory. Okay, so now I will discuss these four methods, 4 or 5 methods: append method, remove method, insert method, lookup method and count method. Here I will show you how these methods change the data in the memory, and what are their time complexities. Okay, so first of all I will discuss the append method. Please see this append method. This append method has a time complexity of O of 1. So this we can see that I am executing the append command by writing array.append banana. So you can see that all things are same, that apple was stored in 635 location, orange was in 6352, grapes was in 6353, mango in 6354. So initially you can see that when we didn't execute this command, the data was stored up to mango, and 6355 was initially empty and there were no fourth index. Okay, so basically this append method, what append method do, it just add the banana at the consecutive location that is empty. Okay, So it just add the banana after the mango. Okay, that is at the last index. So guys, you can see that there is no traversal. Okay, traversal means whenever we need to reach these all the elements, or we need to traverse through all these elements, then the time complexity at that time becomes O of n. But you can see in this operation we just add an element at the end of the array in a at a continuous location. So this operation, append operation, has the time complexity of O of 1. Okay, so I have this shown you at by adding banana. Now you can again see that I have also added guava. Okay, so what it does again, it basically add guava after banana at a continuous location. Okay, so in this case also we did not have to traverse through all these elements. We simply just add the element at the end of the array. Okay, and create an index by. Okay, so now I will discuss the another method, that is remove method, and it has time complexity of O of n. So guys, you will see here that to execute this method we have to traverse through the sum of the elements, okay, of the array. So you can see, that I have removed the orange. Okay, I have executed the remove command of orange. So in previously you can see that we have, after adding all these things, we have apple, orange, grapes, mango, banana and guava. Okay, and I am removing orange. Okay, so what will happen if I will remove the orange here? Okay, in the next slide you will see that you have seen that the orange has been removed. The command was written here, array dot remove orange. So what will happen? So first of all I am showing you the result. So first of all I will tell you the solution. What will happen, that this orange will be removed from this location. Okay, so at 6352 orange will be removed, and then grapes will come to the orange position. Okay, that is grapes will come to the 6352 location, then mango will come to the 635 location, and the banana will come to 6354, and then guava will be 6355. Okay, and then this fifth index will be removed, and there only fourth the array will be up to fourth index. Okay, so guys, in this case you see that we have to traverse through these elements of the array. That is, we have to first remove array from this 6353 location, and then add it to 6352, and then we remove 635 mango from 6354, and then add it to 6353. Then we remove banana from this location and add to this location. So now I am showing the final result. So you can see that the grapes has come to 6352, mango has come to 6353, banana has come to 6354, and guava has come to 6355. So basically we have to traverse through the elements of this array. And in the append method you saw that we do not have to traverse to any element of the array. We just have to add that element to the memory, to the continuous memory, that is at the end of the array. So you also see guys that I have not traversed to apple. I have only traversed to these four elements, but I am writing the time complexity of O of n. This is because we always assume the worst case. That is, we assume that we take the worst case, that what will happen if the zeroth index will be removed from the array. Then what will happen? It will traverse to the all elements of the array. So basically we assume that the time complexity that will be the, at the worst case, will be the time complexity of the method. Okay, so you can see that this array dot remove time complexity, it has O of n time complexity. Okay, so I am showing you one more example. If in this array I am remove some more I remove apple. Okay, so I have removed first element. You can see that apple, it has 0 index. So now what will happen? It will traverse through all these elements. So grapes will come at 6351 location, mango will come at 6352 location, banana will come at 6353, and then guava will be 6354. So you can see that this we have to traverse, and then we have to change the location of the elements. So finally we have to traverse to the all elements of the array to execute this method, okay, to execute remove method. So that's why we have to traverse to each value. The operation or time complexity of this method is O of n. Now we are coming to insert method. So again you will see that in insert method also we will have a time complexity of O of n, because we will have to traverse to the all of the elements, okay. So you can see that I have added cherry at the index 2. So what will happen? Cherry will be added to index 2, and the banana that was at initially 6353 location, that I will show you. Banana was at 6353 location. So what it will do? It will remove the banana from 6353 and add to it 6354. And guava was at 6354 and it has been moved to 6355. Okay, and index 4 has been created. So you also see that here some type of traversal was also done. So that's why the insert complexity is also O of n. Okay, now I will discuss lookup method. So lookup method is basically when we are using square bracket and to reach an index. It is a simple O of 1 operation, because it is just looking at an index, okay. So this method is O of 1 and I am not discussing it further. Now I will discuss the count method. And count method basically does not change the data in the memory, but it try to read the data in the memory, and by trying to read it try to read the data in the memory, and by trying it traverses through all the elements, okay. So we will implement this count function in the coding, and you will see that the count method will traverse to all the elements of the memory. So the time complexity of this method becomes O of n, and I will show you this method in the coding. So guys, let's see here why this count method has a time complexity of O of n. So I'm also write here time complexity of O of n. So you can see that first of all I have an assign an array. So this 1 1 2 3 4 5. Now you know that how these will be assigned in the memory. These will be assigned in the continuous location, okay. So now to find out, now first of all we are going to write our own count method, okay. And then similar methods will be we assume that similar method will be there in this count method, okay. So see here, how will I implement my own count method? So first of all I will write count is equals to 0, okay. So suppose if I want I want to count how many ones are there. So I will write for I in for item in A, ठीक है, okay. And I write if item is equals to 1, increase my count with 1, okay. And finally I will write print count, okay. So how much is coming? The 2 is double. So you can see 2 is the count of 1 is coming 2, okay. If I write here like 4, then count will come 1, okay. So you can see that in this case we have to traverse through these all the elements, okay. So and you already noticed that whenever we have to traverse through all the elements, the time complexity of that method becomes O of n, okay. So whenever we write array dot count and we write some value in that, then they in the count method there is something like this iteration or traversal will be there. Okay, so that's why the count method has a time complexity of O of n. Okay, so guys, one more method, that is pop method, that I have not discussed yet, so I want to discuss here. So what if I write a dot pop? So you can see it just removed the last element in the array. Okay guys, so we have already seen that there is a remove function, but what is that? We have to write in the remove the element which you want to remove. Okay, and it is not necessary that the element that you want to remove will be last one. Okay, so if the element is we want to remove is in the middle, then we have to traverse through the all the element. Okay, so that's why the remove function was having the time complexity of O of n. But when we are writing a dot pop, the pop method always delete the element at the last of the array. Okay, so you can see that in the memory we have already discussed that these will be continuously stored in the memory. Then what will this a dot pop method will do? It will go to the last element and will remove that element from the array. Okay, so you can see that in this case we have to do no traversal. Okay, so that's why the time complexity of this function will become, this method will become O of 1. Okay,